Hello everyone, you are hearing me on Tech with Yellow. Today we are gonna find out whether overcharging affects battery life. If you just wanna know if this will affect your battery life, like the video and fast forward to 4 minutes and 45 seconds. Or bear with me for the explanation. First, let's try and understand what happens in the phone when it's charging and what happens when it reaches 100% but is still plugged in. In order to charge our phones, we need to provide a potential difference aka voltage and current. If you don't know what voltage and current means, then let's use this analogy. Assume a road full of moving vehicles. Speed of those vehicles is voltage and number of vehicles is the current. Electricity is the movement of electrons. Speed of those moving electrons is the voltage. You gotta know these two define the charge of the battery. We'll analyze voltage and current over the course of charging and see how the battery behaves with time with an experiment. Let's plug in the charger to a fully drained battery equipped phone and we'll connect the USB cable to a voltmeter and ammeter. These are the devices that measure current and voltage rate. Voltage at 0% charge is 4.66 voltage and current is 1 ampere. It takes around 4 hours for my phone to charge fully. After that, I'll leave the phone plugged in for another 12 hours. We'll split this into 8 parts from 0 to 100% and post 100%. We already have the reading for 0% charge. We'll observe the readings again at 0%, 25%, 50 and 100%. After 100%, we'll split the 12 hours plugged in time as 4 into 3 hours part. I'm gonna show you how charging current and voltage changes over time. Now I'll read you the voltage and current rates as charging progresses from 0 to 100%. On 0%, voltage is 4.66 volts and current is 0.42 amps. On 25%, voltage is 4.62 volts and current is 0.91 amps. On 50%, voltage is 4.68 volts and current is 0.91 amps. On 60, 4.71 voltage and current is 0.78 amps. On 75, voltage is 4.79 voltage and current is 0.69 amps. On 98%, voltage is 4.96 voltage and current is 0.27 amps. When the battery reaches 100%, voltage is 4.96 volts and current is 0.32 amps. Now notice that the voltage gradually increases from 0 to 100% and current gradually decreases from 0 to 100%. Now after reaching the 100% marks, I'll let the battery charge for another 12 hours more and we'll take readings every 3 hours for 4 times. 3 hours post 100%, battery potential difference is 4.96 volts and current is 0.28 amps. 6 hours later, battery voltage is 4.96 volts and current is 0.27 amps. And after the 6 hours mark, I switch my phone off and let it to charge. After 9 hours, battery voltage is 5.02 volts and current is 0.05 amps. And after 12 hours, battery voltage is 5.02 volts and current is 0.05 amps. We have our required current and voltage data now. Your phone charges more faster for the first 50% and then slows down the charging speed post 50%. This is because charging is kind of like packing passengers inside a car. Initially, it is easy to accommodate people, but as the car gets more and more full, it takes lot of pressure to get the last couple of people inside. Similarly, it is easy to fill the battery with charge initially, but as the battery gets more and more full, more of the potential difference or voltage is required to push the charge inside. But you cannot exceed a certain amount of potential difference and hence charging speed is slowed down after 50%. This explains the increase in potential difference with the change in time in our data. Now let's take a look at our charging data. So initially at 0% charge, potential difference is 4.66 voltage and current is 0.92 amps. As the time progresses, voltage increases for the reason we discussed before and current decreases. Now current is decreased because we don't want to pressurize the battery with more and more charge towards the end of the charging, hence keeping the battery healthy. Once the battery reaches 100%, voltage still increases and the current gets decreased, which means some amount of charge is still pushed into the battery with more pressure. Because when phone is turned on, it keeps drawing power from the battery to perform background tasks such as checking messages and location transmission. As the battery depletes, it's charged from the power source back to 100%. This keeps happening over the night, hence increasing the number of charge cycles. We know that batteries lose their charge retention ability over charging cycles. That is, when a battery is charged again and again, its ability to hold charge decreases, thereby decreasing battery capacity. When I conducted the same experiment after switching off the phone, no current or negligible amount of current only was drawn after reaching the 100% mark, because no background activity is happening and hence not increasing the charging cycles. Now we know that overnight charging does affect your battery, and also we know that when you switch off your phone and let it to charge overnight, it does not affect your battery. But to what extent that overnight charging affect your battery? It really does not make a phenomenal change in battery capacity and all. Serious battery capacity reduction will only be felt after 4 or 5 years. But we usually change our phones within 4 years, and we cannot sacrifice our convenience for the sake of battery life concern, which is gonna come after 4 years. That brings us to the end of this video. If you like the video, hit the like button. And don't forget to share the video with your friends and fam to whom this will be useful. Bye bye.